A gas is one of the five states of matter. The particles are spread out with empty spaces between them. The kinetic theory provides a model that is used to explain the property of solids, liquids, and gases in terms of particles that are always in motion and the forces that exist in between them. The kinetic theory assumes that gas particles do not attract or repel each other. Gases are free to move within their containers without interference from other particles, that gas particles are much smaller than the distances between them. However, the kinetic theory assumes that gas particles themselves have virtually no volume. The kinetic theory also states that gas particles are in constant motion and the collisions of the particles are completely elastic to where no energy is lost. Final assumption of the kinetic theory is that all gases have the same average kinetic theory at a given temperature. If a gas particle that has a small mass like hydrogen that was traveling at a velocity of 10 feet per second, and if it were to collide head-on with the xenon particle, which has a greater mass and was traveling at the same velocity, even though they both have the same velocity, the xenon particle has more kinetic energy due to its greater mass. The xenon atom will transfer some of its energy so that the hydrogen particle will have the same kinetic energy as the xenon particle. Boyle's law states that the volume of a given amount of gas held at constant temperature varies inversely with the applied pressure when the temperature and mass are constant. If we were to put a balloon or marshmallow into a vacuum chamber and decrease the air pressure surrounding the object, the volume of the gas inside the object would increase because gas particles are becoming further apart. The first equation we are going to do is for Boyle's law, and the equation for this is P1 times V1 equals P2 times V2. If the initial volume was 500 milliliters at a pressure of 1 atmosphere, when the volume is decompressed to 1000 milliliters, what is the pressure? So the first thing you do is to substitute all of your variables for numbers that you can. So 500 milliliters times 1 equals 1000 milliliters times n. So 500 milliliters times 1 is 500, and 1000 times n is just 1000n. So you end up dividing 500 by 1000 and just get 0.5 equals n. When a gas is compressed, there are more particles that exist in a square unit area. The size of the particles doesn't change, but what changes is the amount of empty space that is between them. Jacques Charles's law states that the volume of a given amount of gas held at constant pressure is directly proportional to the Kelvin temperature. As the temperature goes up, the volume also goes up, and vice versa. This gas law can also be applied by adding heat instead of removing it. Since this can't be applied to a balloon because it will pop, we will use a tank with a balloon connected to it. If the tank of gas, which was at atmospheric pressure, was heated, the expanding gases would increase the volume of the balloon. The next equation we're going to do is going to concern Charles's law. The equation for that is V1 over T1 equals V2 over T2. If a balloon is filled with 0.5 liters of CO2 at 32 degrees Celsius and placed into a cup of liquid tetrafluoroethane, which has a boiling point of negative 26.3 Celsius and atmospheric pressure, what would the volume be in liters with changed temperature? So you're going to substitute your variables, and you're going to have 0.5 divided by 305 equals n, and you're trying to get n, divided by 24.6. So 0.5 divided by 305 is 0.00163. And then you multiply that by 246.7 to get n by itself, and you end up with 0.404 equals n. If the amount of gas in a container is increased, the volume increases. And if the amount of gas in a container is decreased, the volume decreases. Dalton's law of partial pressures states that the total pressure of a mixture of non-reactant gases is the sum of their individual partial pressures. If there are two gases in a container, each gas will still be colliding with the side with the same kinetic energy, so the pressures are added from the two separate gases. There are some other gas laws that are definitely notable. First is Avogadro's law. Volume 1 divided by number of moles 1 is equal to volume 2 divided by number of moles 2. Second is the combined gas law. Pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. Finally is Dalton's law of partial pressure. So the total pressure is equal to the pressure of gas 1 plus the pressure of gas 2 plus the pressure of gas 3 up until infinity. The final things are non-ideal gas laws. The equation PV equals nRT can be used to describe ideal gases, but there are no ideal gases, and PV equals nRT makes a couple of assumptions. So Johannes Diderot created an equation that would correct the ideal gas law, which is P plus n squared times a squared over v squared times v minus nb equals nRT. A and b must be gathered empirically, and so you're going to have find a table for these if you want to solve this equation.